Good morning. Today, let us study about chemical equilibrium. What is chemical equilibrium? There are two types of equilibrium, chemical equilibrium and physical equilibrium. Before we study chemical equilibrium, let us study the chemical reactions. What are the different types of chemical reactions? There are two types of chemical reactions, reversible chemical reactions and irreversible chemical reactions. Irreversible chemical reactions are reactions in which the reaction takes place in only one direction, that is in forward direction. The reaction takes place in only one direction. Okay, for example, explosion reaction, combustion reaction, precipitation reaction. There are several reactions or irreversible reactions. Now, what are reversible reactions? Reversible reactions are reactions under the same condition, both the forward reaction and the reverse reaction takes place under similar conditions. Both the forward reaction and the reverse reaction, that is, the reactants are converted into products, the products are converted into reactant at the same time. Okay. So let us see an example of chemical equilibrium. For example, H2 plus I2 gives reversible arrow, means reversible arrow 2HI, or Haber process. Nitrogen plus hydrogen gives ammonia. They are all equilibrium process, reversible process. Reversible process are also called equilibrium reactions, chemical equilibrium. Okay, for example, H2, let us take in a glass vessel, H2 plus I2 gives, we are taking only H2 plus I2. What is the color of hydrogen? Colorless. What is the color of I2? Reddish vapors. Okay. So it will be red in color. In the beginning, at T equal to 0, it will be red in color. On heating, after some time, the color decreases. The color intensity decreases and it becomes not red, very red. So, because of the formation of colorless HI is formed, which is colorless. Therefore, the color decreases, red color decreases. At equilibrium, the color becomes constant. There is no change in color. It becomes, that means it attains the equilibrium. For example, you can also, this is manometer, you can measure the pressure change. First, in the beginning, there will be change in pressure. Okay, it will push. So it will be change in pressure. After, once the equilibrium is reached, there is no change in pressure and also there is no change in color. Similarly, let us look at water, liquid water in equilibrium with the vapor. First you take water only, you have water only, so there will be no vapor, pressure will be very less. After some time, when you heat, the molecules at the surface will escape. The molecules at the surface will escape as vapor. It will become vapor because at that temperature, at high temperature, you are giving heat. Therefore, the molecules at the surface will have greater energy and escape from the surface, and it will become vapor, and it will push. Therefore, the pressure changes at equilibrium. Once it will change, after some time there will be no change in pressure. That means it has reached the equilibrium state. No change in pressure, no change in color, no change in pressure. The equilibrium is reached at particular temperature. Okay, now let us this is liquid water is in equilibrium with the vapor. This is chemical equilibrium and this is physical equilibrium. Okay, now let us see rate. Let us see the plot. Let us plot the rate of the forward reaction and rate of the reverse reaction. Okay, so both the reaction takes place under similar conditions. That is reversible reaction. That is chemical equilibrium. Therefore, rate of forward reaction is directly proportional to the concentration of product of the concentration of H2 and I2. I2, suppose hydrogen, iodine are very in the beginning in large concentration. Therefore, rate is very, very high. As time goes by, the rate of forward reaction decreases because the reactants are converted into products. therefore the concentration decreases, therefore the rate of forward reaction decreases and decreases. Similarly, rate of reverse reaction is 0 in the beginning at time. Because why rate of reverse reaction is 0? Rate of reverse reaction depends on the concentration of HI. In the beginning, HI concentration is 0. Therefore, rate of reverse reaction is 0 because there is no HI. Reverse reaction cannot take place. And as the time progresses, products are formed, HI is formed, therefore rate of reverse reaction increases with respect to time, and then this state is called, there is no change. That is, rate of forward reaction is equal to rate of reverse reaction, that is equilibrium. Therefore, at equilibrium, rate of forward reaction, this is rate of forward reaction, decreases, rate of reverse reaction increases, equal to rate of this. Okay, similarly, you can follow the concentration of reactant. Concentration of reactant, what will happen? Concentration of reactant decreases. Concentration of reactant decreases, therefore rate of forward reaction decreases. Therefore, it decreases. And concentration of product, what will happen? Concentration of product with the time product 0, HI concentration is 0 and it increases, and there is no change. See, this is equilibrium, there is no change. Here there is a change, and now after this time point, at this equilibrium is reached, there is no change in the concentration of product or reactant. Okay, so what are the characteristics of equilibrium state? What are the chemical equilibrium? At equilibrium, there is no change in the observable properties. There is constancy of observable properties such as color, pressure, density. There is observable properties. There is no change. There is no change in the observable properties at equilibrium, because color, there is no change, pressure, no change, density, etc. The equilibrium is it looks like static, but it is the equilibrium is dynamic. At equilibrium, the reaction has not stopped. At equilibrium, the reaction has not stopped. But rate of forward reaction is equal to rate of reverse reaction. In the beginning, rate of forward reaction is greater than rate of reverse reaction. Okay? Whereas at equilibrium, after equilibrium, rate of forward reaction is equal to rate of reaction. That means the reactants are converted into product. At the same time, the products are converted back into reactants. Okay? Therefore, it is a dynamic equilibrium. It is not static equilibrium. And therefore, rate of forward reaction equal to rate of reverse reaction. The equilibrium is attained close to the cell. You see, we are close to the cell. The equilibrium is attained only in close to the cell. If you open it, it will escape. There will be no equilibrium at all. So it can be attained from either side. You can take, for example, I can take HI. If I heat HI, it will give H2 plus I2, and then H2 plus I2 will give product. So reverse, it can be obtained from this side. I take the product as reactant, I heat it, then the equilibrium can be attained from taking reactant or from product. Okay. What is catalyst? Catalyst plays an important role in chemical equilibrium. It fosters the attainment of equilibrium. For example, 1 hour if it takes, the reaction will be very, very slow. The equilibrium will take long time to reach. But in the presence of catalyst, it is attained in 5 minutes. 1 hour, not 5 minutes, just 5 minutes, because it accelerates the rate of forward reaction to the same extent the reverse reaction. To the same extent the reverse reaction, and change of temperature for the next condition. Change of temperature, pressure, concentration favors either forward reaction or backward reaction. Okay. Now let us study about law of mass action. What is law of mass action? This is very, very important in chemical equilibrium. For example, let us consider an equilibrium chemical reaction. AA plus BB gives reversible reaction MC plus MD, where A, B, M, N are stoichiometric coefficients. When you balance, stoichiometric coefficients are obtained by balancing the chemical reactions. For example, 2NO, you will get, due to balancing, for example 2H2, when you 2, so N is 2 here. Okay, now according to the law of mass action, the rate of forward reaction or rate of reaction is directly proportional to the active product of the active masses of the reactants, to the power raised equal to the A and B are stoichiometric coefficient. Therefore, the rate of forward reaction is equal to proportionality constant. K of is proportionality constant. Rate constant for forward reaction, concentration of A to the power A, concentration of B to the power B, small b. Okay, now what is active mass? We have given concentration here. I told in the definition the product of active masses of the reactants. Here, active mass is directly proportional to concentration. Active mass is directly proportional to concentration. Concentration is more, then active mass is more. A gives proportionality constant gamma C, where gamma is the activity coefficient. For dilute solution, or if you take for dilute solution, gamma equal to 1. In that case, activity is equal to concentration. That's why we are used to concentration instead of activity, because activity is equal to concentration when gamma equal to 1 for dilute solution. Therefore, I have used to concentration. Okay. Similarly, let us apply the law of mass action to the reverse reaction. The rate of reverse reaction is directly proportional to the product of active masses of the products raised to the power equal to their stoichiometric coefficients. Where Kr is P, therefore or rate of reverse reaction equal to Kr into concentration to the power m, concentration to the power n, where Kr is the reverse rate constant. As I said, at equilibrium, rate of forward reaction is equal to rate of reverse reaction. Therefore, you can equate this one and this call as 2. Therefore, 1 equal to 2. Okay. Therefore, 1 equal to 2, and then I just Kf divided by Kr. I just bring it here. Okay. Kf divided by Kr equal to Kc. Kf by Kr is nothing but a constant. It is another constant, equilibrium constant, Kc, concentration of the products divided by concentrations of the reactant. Always Kc, concentration of the product divided by concentration of the reactant. Now, where Kc is an equilibrium constant, it depends on the temperature. It has unit. For example, moles per liter. What is the concentration of unit of concentration? Moles per liter. For example, M1 or 2. So you will get K may have unit or may not have unit. If it gets cancelled, it may not have unit. Okay. So what are the significance of K value in terms of concentration? The next class we will see in terms of partial pressure, because there are several gaseous reactions. We will see K value is very, very large. What is the significance? This is often asked. When K value is very, very large, the numerator is large. That means numerator is K value is very, very large. The products are present in large concentration. Therefore, the products are present in large concentration means no reactant. Reactant is very, very less. Therefore, it goes to completion. The reaction goes to completion. When K value is very, very, very large, then it is irreversible. It becomes, the product is very, very large, no reactant. It becomes irreversible reaction. If K value is very, very, very small, opposite, it goes to completion. K value is very, very, very small, then the reactants are present in large concentration. Denominator is large, that's why it is small. They are present in large quantities. The reaction does not occur at all. The reaction does not occur in the forward direction. It will not. So, for the equilibrium process, K value is neither large nor low. it is intermediate. Then only the reactants will be converted into product, and product will be converted into reactants. For example, I am writing the reverse reaction. Okay, MC plus ND gives AA plus BB. Then what is the equilibrium constant for this equilibrium process? Then 1 by Kc. 1 by Kc is the equilibrium constant for the reverse reaction. Now let us see some problems may be asked. NO plus 1 by O2 reversible are NO2 this K1, and now I multiply 2 and 2 O2 plus NO, this is K2. What is the relation? You are given K1 and K2. Okay. So what is the relation between K1 and K2? Therefore K2 equal to K1 square. If you substitute K, you can use this formula. K, you can find out NO2 K1 equal to NO2 divided by concentration divided by NO concentration of O2 to the power 1 by 2. Okay, similarly you can write for this, you can find the relation between the K1 and the K2. Now let us see stepwise formation constant, overall formation, overall equilibrium. A gives B K1 equilibrium constant, B gives C equilibrium constant, stepwise K2, C gives D, and A gives D. A, reversible or reversible reaction to give D. Therefore, the overall equilibrium constant, this is stepwise equilibrium constant. Therefore, K equal to, you are given K1, K2, K3, then K equal to K1, K2, K3. This is I have discussed in overall stability constant of the complex, overall stability constant of the complex by back bonding. I have discussed. Please see the video. In the next class, we will see the relation, we will see Kp in terms of partial pressure, and also we will see the relation between Kp and Kc. Okay, thank you for watching.